Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello viewers, my students and subscribers. There is another problem on Trusses for you to enjoy watching and learn from the solution. But if you want to anticipate the solution, you may do so by pausing the video. So compute the bar forces in the bars noted as C and E. Also specify the zero force members by putting 0 on the bar. All acute angles are 45 degrees. So here's the figure, and we analyze this by noting or labeling that this is joint 1, joint 2, and the reaction forces will be as shown. The horizontal component of reaction at 1, which is a pin support, is 0 because there's no inclined load. So summation forces horizontal 0, so definitely that's 0. Let's call this R1Y and this one R sub 2. For zero force members first, you look at that joint, this is 0. By the way, the angles are 45 degrees and opposite sides of 45-degree angle would be equal. So to simplify the solution, I just denote this part of the right triangle of a 45-degree angle as 1. You may call that as A units, but you can cancel A, so to for simplicity, just call that 1. This is also 1 meter. So 0 first member, beginning here, it's 0 here. Then we proceed to look at this joint. These two are collinear. This member is unique. It's like removing that. So this is also 0 force member. Then at this joint, this is 0, obviously. And at this joint, this is a 0 force member. At this joint, which is similar to that, that's a 0 force member. Then we proceed looking at this joint. These two are collinear, therefore this is the unique force, the line of action, so that is 0. So I hope that you understood and you can quickly identify 0 force members, which is a requirement to facilitate the analysis. Although these 0 force members are not important in determining the member force of C and E. So if you look at joint 1, because this is 0 and the angle of each member is equal to 45 degrees, summation forces X, definitely the X component of this member equals the X component of that member. Therefore, these two members have equal stresses, so I'll call them S1 as shown. So by the way, let's solve for the reactions first before we can isolate joint 1 to solve for the stresses of these members here. Same is true after R1Y, we solve for R2, and we can say that these two members have equal stresses also. We'll call that S2. Then, having known this, I consider this section here. 3 more forces are involved, including C, but this member here and this member meet at this point. I'll call this joint 3. Later, we sum up moments about that point to solve for the member force of C. Then, knowing the member force of C, which is a requirement, to solve for the member force of E, we plan to isolate this joint, so we need this member force. I'll call this C sub 1 later. Then we section this part and considering the portion to the right so that we can solve for C1. The final part to solve for E is to isolate this joint. Summation forces vertical, then we can find E. So that's the flow of my solution to this problem. So summation moments about 2 equals 0, clockwise positive. So R1Y times 2 meters, 1, 2, plus 100 times 3, so that's 3 meters, then equals 50 times 5, 5 meters, that's 5 meters. So R1Y times 2 plus 100 times 3 equals 50 times 5. So R1Y can now be solved. It is equal to negative 25 kilonewtons. So it is in the opposite direction. Likewise, summation moment 1 equals 0. Counterclockwise positive. So R2 times 2 plus 50 times 3 then equals 100 times 5. So R2 is equal to 175 kilonewtons. So upward. So negative 25 upward also, but it is negative. So it checks because 50 plus 100 plus 25 supposedly downward is 175. So again, if we isolate joint I, we can say that this member and that member have equal magnitude. So I call that S1. S1 also. Remember the angle that each make with the horizontal is 45 degrees. So summation forces Y at joint 1 equals 0. So we have S1, the vertical component is S1 sine 45, then we multiply it by 2 because there are two forces with equal Y component, and in fact they are equal. Then plus negative 25 equals 0. So S1 sine 45 times 2 plus negative 25 plus R1Y equals 0. So S1 can now be solved. It is equal to 17.678 kilonewtons. Then I introduce this section here. Let's solve for S2 first. This is also S2 by symmetry, and the angle that each force makes with the horizontal is 45 degrees. Summation forces Y again equals 0. S2 sine 45 times 2 plus 175 equals 0. So S sub 2 is negative 123.744 kilonewtons. So I introduce this sectioning here and consider forces to the left of that section AA. So we have to introduce the forces. I remove this part because this is not section, this is not section. Remove also 0. Then these are the additional unknown forces, including C, as shown. And C, I'll call this point 3 the intersection of this unknown force and this unknown force. So I plan to sum up moments about 3 so that only the member force of C is left and we can find the value of C. So that's C. And by principle of transmissibility of a force, I move C at this joint here. There are two components, horizontal and vertical. And remember R1Y is negative 25. So that's the horizontal component. That just does because I plan to sum up moments about C, so it is not important. It passes through C. The vertical component of C is C sine 45 because that's 45 degrees with horizontal. So C sine 45 degrees. Actually, we may not move C along its line of action and transfer it here because C sine 45, if we consider 3 as the moment center in our moment summation equation, so it is C sine 45 times 2, and 2 sine 45 is square root of 2, which is the length of this distance, which is the perpendicular distance of C from point 3. which is square root of 2. Square root of 1 square plus 1 square is square root of 2 meters. So because that's 45 degrees, 45, so that's 90. So C is perpendicular to this distance. This square root of 2, that is the same as C sine 45 times 2. 2 sine 45 is square root of 2. I hope you can check that. So it is not required to move C along its line of action, but since I already I have already done that, so let's just continue. In the second part, we will not do it anymore for the analysis of the force of this member, so that we can analyze E later by isolating this joint. So summation of moments about 3 equals 0. S1, by the way, is 17.678 kilonewtons. So there are two components, horizontal and vertical, but I also move this by principle of transmissibility of a force here. There are two components, horizontal, which is not important because it passes through 3, and the vertical component, which is S1 sine 45, and S1 is 17.678. So that's the horizontal component of S1. We will now move S1 there, and the vertical component is S1 17.678 sine of 45 degrees as shown. Sine of 45 degrees as shown. So summation of moments about 3 equals 0. So take note that these are just the move components of forces. So these are included, although we consider forces to the left of section AA. But remember, originally these two forces come from, for C it comes from here, and for S1 it comes from 1. So counterclockwise positive, so C sine 45 degrees times 2. As I said, 2 sine 45 is the same as square root of 2, which is this square root of 2, plus 17.678 sine 45 times 4. If I have not moved S1 along its line of action here, the moment arm of S1 would have been square root of 2 plus square root of 2, which is 2 square root of 2. And 2 square root of 2 is the same as 4 sine 45. Evaluate 4 sine 45, that is the same as 2 square root of 2. Then plus 50 times 2 plus negative 25 times 1. So plus 50 times 2 plus negative 25 times 1, because that is also counterclockwise. Then equals 0. No more forces involved, equals 0. 100 is not included. R2 is not included also, as well as this S2 here, because we consider forces to the left of this section. And as I explained earlier, these are just the components of forces moved from this original position of these forces. So from there, we can solve for C, and C is equal to negative 88.39 kilonewtons, so it is a compression force. We then consider this section, BB, and the forces to the right of that section. I'll call this C sub 1. C sub 1, the force of this member. This is important to solve for the member force of E later. So that section, I isolate another figure. Let's draw another figure here to clearly show the forces involved. That's the section, and we have 4 members cut. R2 is 175. This is S2, which is negative 123.744. Then this is the other unknown and the other unknown. When extended, they meet here. I'll call this point joint 4, joint 3, joint 4, and we sum up moments about 4 equals 0. This time, I will not move S2 and C1 anymore along its line of action because the moment arm of C1 is square root of 2 meters, which is this. And the moment arm of S2 is square root of 2 plus square root of 2, so 2 square root of 2 meters. So that's 1, 1, 1, 1. And that's square root of 2 meters. This is also square root of 2 meters. So summation of moments about 4 equals 0, clockwise positive. So we have C sub 1 times square root of 2. The value of S2 is negative 123.744. So summation of moments about 4 equals 0. C sub 1 times square root of 2. Then plus negative 123.744 times that moment arm, which is 2 square root of 2. Then plus 100 times 2 plus 175 times 1 plus 100 times 2 equals 0. So from here, we can now solve for C sub 1. C sub 1 is equal to negative 17.677 kilonewtons. We then isolate this joint here. I'll call that joint 5. And there is the free body diagram. C is involved. We have 2 additional forces. Not important because we plan to sum up forces vertical. C sub 1, which is negative 17.677 kilonewtons. So this is the free body diagram. This is C, negative 88.39 kilonewtons. This is C sub 1, negative 17.677 kilonewtons. And we have downward force E, the last unknown. So summation forces vertical equals 0, downward positive. So we have E plus negative 88.39 sine 45 plus negative 17.677 sine 45 equals 0. So E plus negative 88.39 sine 45 degrees plus negative 17.677 sine 45 degrees equals 0. So we can now solve for E, and E is equal to 75 kilonewtons, so positive, so it is tension. So that's it for this problem. I hope that you gain another technique in analyzing trusses, and for any trusses that you will encounter in the future, no matter how complicated, you will find them simple because of this example here.